This conference will now be recorded.
All right. Well, thanks everybody for joining us. This is our bi-weekly meeting. And so today we have Jordan, what's your last name? Jordan Tyndall, right? Jordan Tyndall, right? Jordan is our one of our interns for the summer, and she goes to Georgia Tech, and she has before she came to ELCAS was involved with Candida building and living building cycle, and has a presentation she wants to share with us. And I think it's be a cool opportunity for us to learn. So let's listen in.
Yeah, so hi everybody. I'm Jordan, as Anish said. I am no means an expert on mass timber and construction, but I'm very familiar with the Candida building, so I'll be happy to share what I've been able to learn over this past semester. So the Candida building opened early this spring, the early spring semester, and it's one of the new buildings that takes on the Living Building Challenge, and so it's seeking to get certified by the Living Building Challenge and seek that certification, and also it's LEED Platinum. So it's really interesting. It's great research building for our campus, and it's a great piece of architecture that can show like what can be achieved in terms of sustainability and equity on campuses and outside of campuses. So specifically talking, oh, I don't know what's going on. How am I supposed to go back? Next. Okay, there we go. So about the Candida building a little bit, just about the design of it. It's supposed to take a very vernacular architecture and kind of use the solar panels as a more front porch type idea. So this is one of the main areas that people usually gather, usually tables and stuff around there. So they really wanted this to be a new center of campus, where people are able to gather and really take in the ideas of sustainability and equity into their daily lives and look at it in a lens of the built environment. So a little bit about the Living Building Challenge, if you're not familiar. So it's supposed to be based on biophilic design, really take ideas from how a flower works in the environment. So taking energy and resources from the environment, but also giving it back. So in the Living Building Challenge, they define a couple different things, that markers that they want to hit. Oh, sorry, that's my home phone. Oh, okay. So there are a couple different markers that they want to hit: place, water, energy, health and happiness, materials, equity, and beauty. So in terms of mass timber construction really hits on the material side of it and really part of the equity side, which can talk a little bit more of the equity side if people are interested. That's probably what I know most about the Candida building, but also the mass timber part is really interesting too. So again, the Living Building Challenge really seeks to not, instead of being up to code and being up to standard and being sustainable, it wants to create positive environmental impacts. So being able to take all these resources and take all the materials that are brought in, but also give back to their community around them, whether that's monetary value, whether that's in the programming, whether that's in the construction and the type of people who are working in the building and around the building, and really helps to build the community. So this is a couple pictures of the inside of the Candida building. There's a lot of wood. It's mass timber construction, as I said, and a lot of the wood pieces are reclaimed and recycled wood, which is something I'll get more into later. But that was one of the imperatives that the Living Building Challenge wanted to achieve and want to see out, that a lot of the wood would be reclaimed or be locally sourced. So here are two of the imperatives defined in the Living Building Handbook: responsible materials and red listing. So responsible materials just defines that the wood should be FSC, or sustainably sourced, salvage, or in any other way. And then the red list defines that they should not use any harmful materials in the building. Probably know more about that than me, but not using PVC, harmful materials, all that. And two other imperatives: responsible sourcing and living economy sourcing. So about responsible sourcing, So they want to make sure that the construction materials are local and they're being brought in from like a certain amount of square footage away from the building, to make sure they're actually putting in money to the economy and putting in money to the community. And then living economy sourcing, where the people who are actually building the building, it is local, and the people who are building the building are local as well. So it's benefiting the community in both that they're helping economically, they're helping socially, and overall it'll create, it suffices for the Living Building Challenge requirements. And then the last one, imperative in terms of materials, are net positive waste. So this really defines that at least one salvage material per 5,500 square meters of gross building area can be adapted or from using an existing structure. So for example, in the Kendeda building, Atlanta is a hotspot for a lot of film sets. So a lot of the salvage materials come from all the fast construction that they do from film sets. And so they took that, bought them off from everybody who's in the film industry, and then used those wood pieces in the Kendeda building. So these are a couple pictures of some of the construction work on the Kendeda building. So they used horizontal and vertical glulam, and there's some steel and concrete structures in this for structural support, of course, but most of the square footage they tried to use mass timber for the construction. And then, so a little bit about the cost and carbon impact. By this diagram, you can see that, concrete versus steel versus timber, it's a little higher in price in terms of square footage, but the tons of CO2 emitted is significantly lower than, concrete and steel. And I think what's really interesting about the Living Building Challenge in total is that, they really try to understand that even though there is going to be maybe some more upfront cost, trying to do responsible sourcing and everything, the long-term effects of, health benefits and trying to get active community and economic benefits outweigh the initial cost by a landslide. So that's what they're really trying to promote by having this mass timber construction in the Kendeda building. And so an interesting feature about the building is this paneling that they did on the bottom of some of the ceiling structures and the bottom of the walkways. So because of the red listing materials, they were not allowed to use a certain type of glue to make the paneling as they originally designed. So the structural engineers actually ended up making paneling from 2x4s and 2x6s. And so it created this interesting design that's visually appealing, but also used responsibly sourced materials. So they used FCS certified materials from local Georgia forestries, and then the other like 2x4s and 2x6s were salvaged pieces of wood from the Atlanta film sets. So this is kind of a small diagram just showing, a brief constructional elements of the certified wood interlocking with the 2x4 spacers, the salvage spacers. And then another interesting equity point from the standpoint of using this method instead of using, typical glue construction, they had to nail all the boards by hand. So it was very labor intensive, and what they implemented was a Georgia Works program, and that program allowed people who are facing homelessness or facing job insecurity to use and to kind of transition back into the workforce. So they used that program to get a lot of people, a lot of manpower to help construct these things, and also it promotes a different level of understanding and a different level of investment in the community. So even though it is on a, what people would say a generally closed campus, a lot of people from outside actually had a hand in building the Kendeda building. And so they actually have like a personal connection to, what the building stands for, what it's trying to achieve. And so it promotes a different equity component that not a lot of us think about. And then the extra wood was salvaged and used. So the bigger beams were used for staircases. There's a ramp as a main feature in the building. And then a lot of the wood pieces were used as stairs, so you can see the facing and you can see the wood grain throughout the building. But yeah, that's all I have. I could talk more about the equity components or any questions that anybody has. Yeah.
That's awesome. I think you should talk about the more of the equity piece. That was, you were telling me a little bit about it. I think it's interesting.
Yeah, of course. So part of our research, we looked at what was achieved in terms of equity and what wasn't achieved in terms of equity. A big part they want to do, especially with the Living Building Challenge, they want to get everybody at the table early on. So constructional engineers, students, professors, the designers, architects, everybody. So a big part of the equity component was creating space for everybody, even though it is a campus and you would think, you know, we're going to have educational spaces specific to sustainable design. They really wanted to make sure that it was open to everybody. So a lot of the classes held, they actually have petitions every semester so they can make sure that the classes are large lecture classes. So they get a lot of students who are, you know, prereqs, so general chem, general physics, all that. So they can get a lot of students and a lot of foot traffic in and out of the space to promote this type of equity and promote interest in sustainability. They also look into signage, so they could talk about and, you know, really have other people understand, you know, the construction elements of it, what went into it, the people who built the building, that was really important to them. So the signage is not up yet, but they're working on graphics to put up. But also just social media wise, they really wanted to promote that this is a building that can be usable by everybody. So they wanted to promote, you know, flushable toilets and the foam flushing toilets. So a lot of people just come to use the toilets, and that brings a lot of foot traffic in and out of the space, which is really important in promoting, you know, equity from that side. And, you know, there's some setbacks from, you know, doing that. They want to make it more exposed to staff, but it's not really it's staff friendly, but they want to do more to attract some older and professional individuals. They want to do more scheduling for outside community partners. So right now they have a K through 12 program that is housed in there, so they can have Atlanta students come and learn in that space so they can feel like that space is their own as well. But some of that, they have a problem with scheduling wise, because it's a campus, they can only schedule like one semester ahead of time. So that's something that they have to figure out in terms of how to promote more diversity in terms of programming. And in terms of like water equity and everything, just because they use all the rainwater and they filter out all the rainwater on site, it prevents like a lot of drain off that happen because, you know, Georgia Tech is a fairly hilly campus. A lot of runoff would happen into surrounding neighborhoods, so that prevents some of the runoff that's happening in surrounding neighborhoods. At the moment, they're trying to make sure that the city water, it can run without city water. Right now it's running with city water. So hopefully once certification happens, they can, you know, switch on and switch off whenever they please in order to achieve that kind of water equity component of the building.
So that means they're doing black water recycling. So that the foam toilets, if people aren't familiar with those, they're basically composting toilets, and it's like a regular toilet, but they have foam that kind of runs down the sidewalls and primes it so that after you do your business, you just shut the lid and that's it. It sort of continuously flows, I think, right? The foam, and it's
Yes.
It's a bio-friendly product, whatever it is, and then they have like a whole composting system in the basement. Do you want to share my screen, and maybe Jordan, you can talk a little bit more about the other features that educate? Do people have questions? this is kind of an interesting section that shows sort of how the solar panels are separated up here. I don't know if you can see my mouse, but the panels are separated a little bit because of the shadow that they cast on each other. So they wanted to maximize that the panels would never be in shadow from each other. So in between each panel, they have a tray that catches the rainwater and collects it. And then the storm water, these are all pervious, and correct me if I'm wrong, but I believe the flow is that this basically infiltrates. So all of these are porous pavings, porous concrete, and then a unit paver, and then these bioswales basically take care of all the storm water. And then I think Jordan, is it infiltrating from, is the roof water collecting, coming down and going into this bioswale as well?
Yes.
That was my understanding. Okay.
Yep.
Which is
so in terms of the landscaping, in order to fulfill the Living Building Challenge requirements, they have to create an eco commons. So their master plan is to create an eco commons right next to the Candida building, and then throughout the campus to, of course, have more green space, but have these porous pavements so they can recycle more rainwater, because there's a lot of runoff that goes on, especially when it rains a lot. It's very hilly, and so having a way to take this water and really use it for something else instead of having a lot of, and to overload the stormwater systems.
Yeah, so the solar panels run north-south in this image, and that's the porch. That whole kind of plaza area to the north there is the porch, and there's this huge existing tree that they worked around, right?
Yes.
Significant old tree. I think they show it there.
Hey y'all, I have a quick question about the lamination process that you were talking about, saying that they had to change the adhesive when they were laminating boards together. Do we know what type of adhesive was used?
That's a good question. I could definitely look and see if I can find information on that, but I don't know what type of adhesive was used.
Did they just nail, or did they do both?
So they just nailed.
Okay. Oh, it was nailed. Okay, I thought it was an adhesive that they used.
No, so they weren't allowed to use the adhesive because it was a red list item. So they ended up nailing all the boards together to create that pattern with the 2x4s and the 2x6s.
Got it. Thanks for clarifying.
And the other interesting thing about this is you have to, one of the petals, you have to grow food on the site. And so they have a roof garden up here that has, I think there's some kind of berry, and I can't remember what else, Jordan.
Yeah, I think there are blueberries and other types of foliage. I don't think there are any other fruits, but I know that there are blueberries up there.
And then this is a green screen they have, and behind that, this huge volume here is the large classroom. It's a flat, flat seating, tables and chairs sort of venue, but you can also set up as rows of chairs as well. It's not like a stepped, what do you call it? Format.
So is it completely powered by the solar panels on the roof, or is it still drawing back?
Yeah, I have a slide there. So it does have to be net positive. So you go through and reduce your loads as much as you can, and then this is they're supposedly going to be neutral, right? Sometimes they end up, the living buildings in general end up creating more power than they thought, or using less than they thought. But I think, Jordan, they still have quite a few months to monitor. They have to monitor for at least a year, right?
Yes, correct.
So this is the goal, is their final EUI is 35, and then hopefully that will be their match their output. And it's pretty well daylit, so I can't imagine they, I mean, there isn't a lot of energy use in the building in terms of labs or equipment. It's pretty minimal. Their classrooms, they're all daylit. And I think naturally ventilated too, right? I think but the humidity is an issue.
Yeah.
But when, I can't remember about the Windows systems. I'm blurring together too many buildings, but.
Is it a radiant slab everywhere, or is it just in those sort of like elevated decks with the concrete?
So what I learned is that this is their classrooms on either side of that atrium space, and offices and classrooms down here as well. That's all radiant slab. This one big classroom volume is a different mechanical system. It's forced air from the top. And I think because it's slab on grade, I cannot remember the reasoning why, but it was a different system on purpose. It might have been the load. Actually, you know what it was? I think it was the ventilation requirement for the amount of people in the space. They had to have a different system anyway, and I believe it was a heat pump. I cannot remember, but there's a huge fan in the ceiling that they blocked out. That's it's kind of an interesting detail, but I'll have to look up more information on that. But I do remember that it's a different system.
So when they submit this as like a living building challenge, and it's two separate buildings, kind of like that, but it's probably really just one project, I guess, and they're kind of using the two.
Well, it is very connected. It doesn't feel like it doesn't seem like two separate buildings, and you often have zoned mechanical systems anyway. So it's all one envelope, right? That classroom opens up to this this hallway space. I don't know if they have an image of it, but it doesn't feel as separate as it looks in this picture. It's just basically one story, right? That's the whole classroom, and it has a movable wall in it, and it can open up also to be more of an event space.
So did this building get the full petal thing, right? The whole flower, basically? Isn't that how the Living Building Challenge works?
Yeah, so they had to meet the requirements of all the petals. It was actually built under the 3.1 standards, not the 4.0 standards for the Living Building Challenge. So they didn't meet some of the new requirements that are in the 4.0 standard. For example, for the equity component, there is a requirement that they have to like donate a certain amount of money to a nonprofit promoting equity and sustainability in the community. And since Georgia Tech was considered a nonprofit at the time, Georgia Tech didn't have to fulfill that part of the petal, but now they got rid of that in the 4.0 standards. So now everybody who builds a living building has to donate a portion of the money to a nonprofit promoting equity and sustainability in the community.
Interesting.
And these slides were put together by the architect for like a 5-minute presentation. So it's kind of interesting. It was very, there we go, Lord X Sargent. They're out of, I believe they're out of New Orleans. But this partnership is pretty unique. The Kendeda Fund itself designated that they wanted to do a living building, much like the Bullitt Center was specifically a targeted, example to the community of sustainability, and that's what the Kendeda Fund wanted as well, and wanted to connect that Georgia Tech or Georgia, the whole community, the wider community, right? And the engineering architecture school. These consultants too, Ander Pogon, they're a pretty progressive landscape architect. If you haven't heard of them, they've been doing this kind of great natural habitat work for a long time. And then Biohabitats also does a lot of consulting on that sort of work as well. So that's kind of all we had.
So is it like a partnership that kind of is separate from the city of Atlanta? Like it's just their own sort of partnership? Like when they partner with the community, do they go to Atlanta or do they just kind of go to community groups, or how does that work? Or how did it work?
My assumption,
Yeah, go ahead.
my assumption is that they just partner with other community groups. I don't think they partner with the city as often. I know they had some relationships, so they developed an equity pedal work group for the building to fulfill the Living Building Challenge standards, and the equity pedal work group partnered with Partnership for Southern Equity, which is a nonprofit based in Atlanta. I think they did have some people that worked in the sustainability side of the city of Atlanta, but it's not a direct partnership like that.
Yeah, I think that makes sense because Atlanta is just a very limited piece of that whole, like what Metro Atlanta is a lot bigger than that, right?
Right.
Cool. Well, thank you for
Jordan
presenting. Oh, go ahead.
Yeah, I was just gonna say Jordan was talking about how she was involved as vertical. Well, you can explain it better, Jordan.
Yeah. So
but I think it's pretty cool that you're so involved with this project.
yeah. So it's a vertically integrated project. It's combines like professors and people in that general like field, and and then other students from other majors. So there were 2 design majors, engineering majors, public policy. So it's just basically coming together and kind of thinking about, okay, what is building and what is equity, and how can we promote equity and sustainability in the built environment, and kind of translating that into either at a larger scale in Metro Atlanta or a smaller scale, just our Georgia Tech community campus. So I'm specifically working on a project to promote equity and sustainability in capstone engineering projects. So developing guidelines to have people think of engineering projects that's not just something that they can tack on at the end of the projects, but something that should be communicated throughout the whole process of designing.
Awesome. All right. Thanks for talking about that with us. I think our next meeting is scheduled for July 10th. I'll see you guys all there. Thank you, Jordan. Let's give a round of applause.
Yeah, nice job, Jordan.
Thank you.
Thanks.